Okay, so let's see how to use the reference angles that we talked about in the last video. So let's say that we've got theta equals 210, and we want to find all of the function values of theta. Now, if you have your unit circle with you at all times, that's not hard to do, but we need to move away from looking at our unit circle every single time we want to do one of these problems. And reference angles are how you do this. So with reference angles, you really only have to remember the first quadrant values, and then you can get everything else from there. So the first thing that we want to do is find the reference angle for 210. Okay, so if you need to draw it out, that's fine. So we'd go 180, and a little bit more would be 210. Okay, so 210 is going to look like that. We're not quite to 270 yet. And so we can see that we're past 180, so we're going to do 210. Our theta prime is going to be 210 minus 180, and that's going to give us 30. So our reference angle is 30 degrees. And the reason that we want to find that is that all of your values are going to be the same as your reference angle. And then from there, you just have to figure out the signs, positive or negative. So look, we're going to do sine, cosine, and tangent of our reference angle. Okay, you might even be able to do these in your head, and that would be fantastic. Okay, so you think of those first quadrant values, and so sine of 30, that's going to be our y value, that's going to be our smaller value, that's 1/2. Cosine of 30, that's going to be our x value, that's the bigger one, so it's going to be square root of 3 over 2. And then tangent of 30 is going to be sine over cosine, and we radicalize that, and we get square root of 3 over 3. Okay, so when you do these often enough, hopefully you're starting to get them memorized. But if you do them often enough, you'll be able to do those without looking at the unit circle. Okay, so now we want to use that to do sine of 210, cosine of 210, and tangent of 210. And then I know you guys can do cosecant, secant, and cotangent just by flipping these. Okay, so now if we want to do 210, it's going to be the same values as our reference angles. So we're going to get 1/2 square root of 3 over 2 and square root of 3 over 3. It's the same values. We just have to figure out the signs. And we're in the third quadrant. You can remember our A, S, T, C thing if you want to remember which one's positive, or you can think of it geometrically, negative, negative for x and y. So we can see here that only tangent is going to come out positive. So that means sine is negative, cosine is negative, sine over cosine comes out positive. And then of course the reciprocals will be the same signs as that, just flipped. Okay, so that's how you use your reference angle to find your actual angle. And if you do enough of these, this part over here on the left should start being something that you can do in your head. You figure out where the reference angle is, what the reference angle is, what the values are, and then it's just a matter of writing down the values and deciding on the signs, whether they're positive or negative. Okay, we can also use this information to do the reverse, to figure out angle values given sine, cosine, and tangent using our calculators if they're not on the unit circle. So let's say that we have cosine of theta is equal to negative 0.825. Okay, so if you use your calculator, it's only going to give you a certain range of values, and we're going to see that when we actually get into the inverse trig functions. We haven't gotten there yet. So your calculator is not going to give you every possible answer to this, because there are infinitely many thetas that you could put in here that would give you this number, because remember they're periodic and they're going to repeat. So it's only going to give you certain values. So if you put this in your calculator, okay, you want to do the opposite of cosine. The opposite of cosine is the inverse function. So theta is going to be, it's actually theta prime, is equal to cosine inverse, and we're just going to put in the positive we're just going to put in the positive value of this because we just want to get the reference angle in the first quadrant. And cosine inverse, sine inverse, tangent inverse, if you put in the positive one, it's going to give you the first quadrant angle on your calculator. Okay, so we're going to do cosine inverse of that number. And when you plug that into your calculator, you should get that it's equal to 34.41 in degrees. Okay, you can do this in radians as well, but I'm in degrees. Okay, so we get that our reference angle is 34.41. So that is our angle, that would be our angle in the first quadrant, but we need cosine to be negative. Where is cosine negative? Cosine's negative in the second and third quadrants. So we need this reference angle in the second quadrant, and we need this reference angle in the third quadrant. So the first one, in the second quadrant, I'm going to have to take 180 minus 34.41. And in the third quadrant, I'm going to have to do 180 plus 34.41. Okay, and that'll give me all my solutions on 0 to 2 pi, which is usually what they're asking for here. Okay, so when we do 180 minus, we get, should be 145.59. And when we do 180 plus, that should be 214.41. Okay, and then of course you can turn around and check them by doing cosine of this angle and cosine of this angle, and you should get negative 0.825, at least pretty close. We may have rounded a little bit here. It should be very, very close. Okay, let's try one more of those. Let's say that we want to find theta if tangent of theta is equal to negative 2.15. And again, we're doing, gosh, I guess I should have said 0 to 360 here since I'm in degrees. Sorry, I put 2 pi. You know what I mean. Okay. All right, so we want to find what theta is. We're given a value for tangent. We want to find what theta is. What angle will give us this answer? So again, we're going to find the reference angle by doing tangent inverse of positive 2.15. That's going to give us our angle in the first quadrant. So when we do that, we plug this into your calculator. It's got to look exactly like that. It's going to give us 65.06. 65.06. So that's our reference angle in the first quadrant. We want tangent to be negative. Where is tangent negative? Tangent's negative in the second quadrant. In the fourth quadrant this time. I should have put this here. This is second quadrant and third quadrant. Okay, we need second quadrant and fourth quadrant for tangent to be negative. Okay, so second quadrant, I'm going to take 180 minus 65.06. And fourth quadrant, okay, to get in the fourth quadrant, I need to do 360 minus 65.06. Okay, so that's going to get me in the second quadrant, that's going to get me in the fourth quadrant. And when you plug those in, you get 114.94. Okay, we can tell that's definitely in the second quadrant. And then we plug this one in and we get 294.94, and that's definitely in the fourth quadrant. Okay, and then you can always go back and double check them, take the tangent of those, and it should be pretty close to the value that we started with.